we have two questions, and I want to make it clear to you that last class which we did was factorization. What we did in last class was finding limits using factorization. So in some cases, we see factorization as a tool to find limits. In this class, the two questions which are given here are basically not on factorization, but another concept called rationalization. So there is something called, one second, rationalization. So in rationalization, what happens? As you can see, the first question, root over x plus 1 minus 1 upon x, limit x approaching 0. Now, if you put x is equal to 0, numerator will come out to be 0 and denominator will also come out to be 0. So this is called 0 by 0 form. Now what happens? How can you solve this now? So what we will do here, we will use rationalization. So in rationalization, we take root over x plus 1 plus x upon root over x plus 1 plus x in the numerator also and in the denominator also. Now we multiply this with this. So we get limit x approaching 0. This is a minus b into a plus b. The identity of a minus b into a plus b we all know is a square minus b square. So this identity will make it x plus 1. Under root ka whole square will be x plus 1. Minus 1 ka square will be 1 upon x into root over x plus 1 plus 1. Now 1 will cancel and you will get limit x approaching 0, x upon x root over x plus 1 plus 1. Now next x will cancel and you get 1 here. Now when you put x as 0 here, now there is no problem in putting it 0. Because if you put 0, you will get 1 by root over 0 plus 1 plus 1, which will simplify to give you 1 by 2. So this is your answer. The limit is this. Actually, at 0, it is not defined, but by rationalization, we get this value as half. Sathya, are you getting the steps which are involved here?
Yeah.
The main
Yes.
thing was rationalization. You have multiplied the numerator and denominator by square root of x plus 1 plus 1 by square root of x plus 1 plus 1. So
Yeah.
these two things has actually played a role and then helped us to find the value.
Yes, sir.
So you can write it down and then we'll see another question also, which was given there.
Yeah, answer.
Next question which we had was root over 5 minus x minus root over 3 plus x upon x minus 1. Limit x approaching 1. So you can use rationalization. How can you suggest? You can't put x is equal to 1 here, because if you put x is equal to 1, what will happen? 5 minus 1 under root minus 3 plus 1 under root by 1 minus 1. This will be root over 4 minus root over 4 by 1 minus 1. This is 0, this is 0.
0, 0.
So you cannot put it like that. So what you have to do, factorization you can't do here. So the option which is remaining is rationalization. So in
Yeah.
rationalization, how would you do?
We can multiply into root 5 plus x minus plus x
Root 5 minus x,
minus x plus root x 3 plus x.
root 3 plus x in the numerator and in the denominator. Fine. Can you try further steps?
Yes, sir.
Please try. Yes, Sathya.
That's the root sort.
Can you just tell me what is the next step? What have you got in the next step?
5 minus x minus t plus x
Fine.
by x minus 1 into root 5 minus x plus root 3 plus x.
Hmm.
The next step I got as 2 minus 2x
Hmm.
divided by same thing, x minus 1.
Okay.
After this, I didn't get.
So can you take 2 common in the numerator?
Yeah, but that will be 1 minus x.
And can you take minus common? Now, can you tell me what it will be?
Minus 1 plus x.
Isn't it this?
Okay, yes, sir.
So this will cancel. Now you put x as 1. So in the denominator with 2 and this as 2. So minus 2 by 4. That will be minus 1 by 2. It's okay.
Yes, sir.
So you did more than 50%. You have to just think that you have to take minus 2 common. Now I'm stopping the share here. First you want to write, you write it down.
Yeah, that's right.
Yeah, now you can share the next third one. Now continuity it is.
Yeah. So I think after this, so then after this slide, we have this slide, this video.
Okay, this
and
is
then-
also there. I thought we
No,
reached
no,
that thing.
this is a video.
This is a video. Okay.
So I think after this is
Isn't it continuity?
yeah, yes, so that's sorry, that's the unit.
Okay, okay.
This one. Yeah. This one.
Yeah. Hmm. Next one. Okay, next one. Mm, 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 ठीक है, next one. Okay, next one. Okay, next one. Next one, Sathya.
Yep.
Next to you. Yeah, this one. No, no,
Oh,
before this.
sorry.
Point discontinuity, jump discontinuity, infinite discontinuity.
Devina, how much is the audit fee? The consultancy fee, professional, you can name it everything. But
Okay.
salary for doing
Next
this
one.
audit. Sorry,
Okay, next one.
75,000 each,
Next
right?
one.
And
So I
we
think
paid
it's the
it
same
for
thing like PT.
Yeah, yeah. Next to this.
75,000. Sorry,
Okay, next thing. This is the same one.
10,300.
Okay, next.
Yeah, that's it.
That's it. Okay, let us. So we can do more than 50% today, or maybe the whole of this.
And
So
how much
basic
we
thing
paid,
here is you have to understand that
plus 50,000 they charge.
you have to understand that you have here limit, a concept of limit, which has to be there again. So continuity, the word continuity,
So,
that is a continuous function. We're talking a continuous. So continuous means there is no break. If you draw a graph,
No problem.
if you
No,
draw a
my
graph
mommy will understand because
like
if we are
this,
going now to,
without any
ask
break
you will
anywhere,
also be
it is
charged.
continuous.
What was the audit fee last time?
If you draw a graph like this, there is a break. So it is not continuous. That means you are drawing the graph without lifting the pen, then it is continuous. If you are drawing the graph with lifting the pen, that is you are drawing till here, and then you have to lift the pen and again draw here. This is not continuous. So this is the concept of limit which you have to understand. So for a function to be continuous, if a function is continuous, limit x tending towards a f(x) is equal to f of a. This is the important thing. So what we mean to say here, that earlier we used to study about limit. So left hand limit is equal to right hand limit. We say limit exists.
Yes, sir.
Now here what we come to in continuous, left hand limit is equal to right hand limit is equal to value at that point. All three should be there. So if I give you an example, like there is a function which is going like this and like this, okay, and there is a function which is going like this, and there is a function which is going like this. So I'm giving you three different functions.
Yeah.
Now this is the x-axis and this is the y-axis. If you take a point A here, A is here also, A is here also, and you talk about the limit at A and continuity at A. So you have to understand this. Look, Sathya, if you have any line not understood, any point not understood, you will ask it there. because this is very important. We are again taking the example of limit, and we are also clearing the concept of continuity. So I don't want you to be stuck there again. So just listen. At A, this f of A is having this value, right? This is the value at A. This is L. If you talk about the limit x approaching A fx, so that value is this value. Suppose call M. So limit exists, that is the left hand limit and right hand limit both are equal. You are approaching A from the left or you are approaching A from the right. In both the situation, you will get M. So I'm writing in one go that limit x approaching A fx is M. You can write it like this also, limit x approaching A minus fx is same as limit x approaching A plus fx is equal to M. So limit exists here, but the value of the function at A is not same as the limit. So what is happening here, that the left hand limit and the right hand limit are equal. So the limit exists, but is not equal to the value at the function at that point. In other words, you have to lift the pen. You will just move the pen, then you will lift it, make a dot here, and then again you will move the pen. So here we say that limit exists at x is equal to A, but not continuous at x is equal to A. So this is what we can say about this first graph. Now I'm moving to the second graph. In the second graph, if you approach A from the left side or from the right side, you will get the same value, M. And if you get the value at A, that is also M. And limit x approaching A, fx is also M. So here left hand limit is equal to right hand limit is equal to value at the function at the point A. And all are same M. So it is limit exists also at x is equal to A and continuous also. That is, you don't have to lift the pen. Clearly, you don't have to lift a pen. A smooth curve is drawn without lifting the pen. In earlier one, you have to lift the pen. In third one, what happens? So in third one, if you see here, what is happening at A, the value is this M. M is the value at A. F of A is equal to M. Limit x approaching A minus. If you are approaching x from negative side, from here, then also M. It will approach M. But if you limit approach x A plus fx, if you approach from the right side, then the value will be, approaching value will be L. So exact value is M, left hand limit is M, but the right hand limit is L. So left hand limit is not equal to right hand limit. Limit does not exist. And as limit does not exist, then obviously it will not be also continuous, because for first left hand limit should be equal to right hand limit, then value at the function is. So not continuous also at x is equal to A. So now tell me, Sathya, where you have doubt and what you have not got.
No, I think I understood this.
You understood this one. So I am starting from here. First write this, then I will scroll down.
I wrote this. I wrote these. I didn't
Okay.
write the graphs.
Okay. This I scroll a little bit more. Oh, one second.
Okay, okay. ஆமா. எங்க அம்மா டென்ஷன் தாங்க முடியல. அங்கிருந்து படிச்சுட்டே இருக்காங்க. பயன்படுற வேலையை தான் போயிடணும். எனக்கு கொண்டு வாங்க. படிச்சு இருக்காங்க. இந்த ஆதார் கிடைச்சா முன்னாடி வந்து போயிட்டு ஆதார் போயிடணும். இப்போ வந்து அந்த சர்வர் வந்து டவுன் ஆயிடுச்சு. மொபைலுக்கு போல. ஓ சரி சரி சரி. ஆ ஆ ஆ ஆ சரி. இப்ப டெனன்ட்க்கு வேற ஓன் ஹவுஸ் இருந்துச்சுன்னா டெனன்ட் கூட வேற ஓன் ஹவுஸ் இருந்துச்சுன்னா ஓகே ஓகே. ஓ ஓ ஓகே. ரெண்டு வீட்டுல நம்ம இருக்க முடியாது. தெரியல. ஆனா வேற வேற வீட்டுல தானே இருக்கேன். வீட்டுல இருந்து ஓ ஓ ஓ. சூப்பரா இருக்கு. இவங்க கண்ணன் நான் மரத்தை நான் பொண்ணு எக்ஸ்பிரஷன் இல்லாம பார்த்தா இன்னொரு ரொம்ப எக்ஸ்பிரஷன் கொடுப்பாங்க. ஆமா ஆமா. இல்ல இல்ல பிளாக் கலர் போட்டுருந்ததுதான் பொண்ணு மாதிரி. ஆமா ஆமா அவதான். ஆமா ஆமா. அவ தெரியும்ல. ஓகே. ஓ ஓ. லைஃப்ல வந்து ஒண்ணுமே இல்லாம எங்கேயோ மழை பெய்யுது, எங்கேயோ குரல் நல்லா இருக்கு. பட் இட் இஸ் நாட் சிங்கிங் வித் யுவர் வாய்ஸ். ஓகே. யாரோ வாய்ஸ் வாய் நடுற மாதிரி இருக்கவங்க அலட்டிக்காம பாடுறாங்க.
So can you scroll down a bit? Yeah. Answer.
Okay. Now you can share again and we'll discuss. I'm stopping share. Yes. So yeah, in this continuity, a function is continuous at x is equal to a if fa is defined. So first of all, fa should be defined. It must exist. Like if fa is not defined, it cannot be continuous. Second, limit x approaching a fx exists. So the limit should exist. Third, the limit should be equal to value of the function at that point, fa. So an easy way to think about it is that a function is continuous if you can sketch the function without taking your pencil off the page. So this is what we did, that without lifting the pencil off the page, we should draw it.
Okay.
Next page. Yeah, so these are some examples of the functions which you can draw without lifting the pencil or pen. And here you can see there is no gap anywhere. You don't need to lift your pencil. So all of these are continuous functions.
Okay.
Next page, you can come to next page. Now this is an interesting case where we will see how much we have understood. So at A, whether it is continuous or not. Do you lift your pen or pencil, or without lifting you can cross A?
A, yes, we can continuously draw.
It is continuous at A.
Yeah.
Then at B
B, it is discontinuous.
and at C,
It's continuous.
C
No, it's discontinuous.
and D,
It's continuous.
fine. So if you further want to discuss why is it discontinuous at B, so can you tell me what is the reason of it being discontinuous at B?
Because it's not continuous, like there is a break.
In terms of that limit, can you tell me with terms of
So because this, it is.
at B? Let us talk about B first.
B.
Yeah.
Uh,
So what is the value of the function at B? Can you just point me that cursor?
yeah.
This, right? And at the left of B, approaching B from the left side, again this same thing.
B. Yeah.
And from the right side, if it is approaching B,
It's B.
no, no. From the right side, if it is approaching, then you have to move above. Why? This is one dot. This is not covering beside B. It
So
seems,
from
it
the right,
seems
it's
from, no, why are you stuck there? This is a small dot. This is not such a big dot that it will come in the vicinity of B. This is just at B.
so this is so B plus.
B plus. B plus, this is not, no, this is not existing at B plus. It is still B. It is still B.
Okay.
After B plus, where we go? At B plus, where we go? What is the definition? Yeah, this is what we have. At B plus, this is the value. At B, this is not included, but B plus, this is included. And at B, this is below value. Similarly, C, what is the value at C?
C it is 2.
No, this is not included at C.
So it's
This one is at C. And C plus?
same.
No, not C plus.
So
C
from
plus this one. And C minus?
C minus is this.
This one. Are you getting little bit now?
Yeah.
Okay. So let us move further slide. Okay, type of discontinuity. Let us discuss. So I am sharing. Jump infinite point. One second.
No.
Yes. So first one is point discontinuity is there, no? Point discontinuity is something like this. I don't actually remember the example which was given there. But point discontinuity is that limit exists, but the value at the point is not equal to limit. That means left hand limit is equal to right hand limit, but is not equal to value at the function at that point A. This is the limit point discontinuity. Another one was jump discontinuity. Jump discontinuity is that if we have limit does not exist, that left hand limit is not equal to right hand limit, that you can say. And that is, there is a jump. It may be something like this here and then here. So there is a jump. as we see from the previous example. This is a jump. In third one, this is a jump. In first one, it was a point discontinuity. At this point, it was not same. Otherwise, limit was existing. And then we have third one as infinite discontinuity. Infinite discontinuity. Okay. Infinite discontinuity is left hand limit and right hand limit are infinite. So you can write this, then we'll see the examples. Written, Sathya?
Yes, sir. Just a minute.
Hello, good evening. I just want to take 1 minute that I will start tomorrow. Yes.
Sir. Done, sir.
Okay.
For free until 3 o'clock.
So you can share.
Yes.
So if you see,
So, sir, should we like solve these or like what do we do?
yeah, you have to solve this. Like if you put x is equal to 2, let me tell you, if you put x is equal to 2, what you get in the numerator?
2 square.
Sorry,
Oh, in numerator we get 0.
and denominator
0.
0. So it is not defined. So at x is equal to 2, it is not defined, right?
Okay.
So this is a point discontinuity. At that point, it is not
Sir,
defined.
we don't we have to do the
एक मिनट कोई आया है दरवाजे पे, मैं अभी आ रहा हूँ.
okay, sir.
Yes, Satya. So if you put x is equal to 2, you will see that the numerator is becoming 0 and denominator is becoming 0. So this is not defined at x is equal to 2. So at this point, it is discontinuous, right?
Yeah.
So this is clear. This is a point discontinuity.
Yes, sir.
Next,
For this, don't we have to take it like x plus 2 and x minus 2 and we cancel x?
that you can do to find the limit. That will make you x plus 2, and when you'll put 2, it will become 4. But you don't have to find the limit. You have to just tell that whether it is a point discontinuity or not. So you
Okay.
will just say that at x is equal to 2, it is not defined. So it is discontinuous as x is equal to 2.
Okay.
Rest you can find the limit and say yes, left hand limit is equal to right hand limit.
Okay. This one. Second. So,
Here,
how do we solve this?
okay, let me take the photo of this, then I will discuss this. Mhm. So in this one, it is given as fx is equal to 4 if x is less than minus 2, and x square if x is between minus 2 and 3, and x if x is greater than equal to 3. So if you see here, left hand limit at x is equal to minus 2 is 4. This is left hand limit at x is equal to minus 2. Right hand limit at x is equal to minus 2, this is in bracket here, is x square. So minus 2 square, that will also be 4. And value at 2, value of fx at 2, at minus 2. So this will be x square, that means minus 2 square, that will be 4 again. If you see the values at minus 2, left hand limit, right hand limit, and value of the function, then all of them are equal. So it is continuous at x is equal to 2, minus 2. But what about x is equal to 3? If you take x is equal to 3, so left hand limit will be equal to, according to this definition, 3 square 9, and right hand limit will be equal to, according to this definition, 3 only, and value of the function at 3 will be, this is equality included, so 3 only. So left hand limit is not equal to right hand limit here. So it is a jump discontinuity. Getting this?
Yeah. Yeah.
So write this down.